Um,
Did you want me to kick it off?
sure. Got it.
All right. Good morning. Good evening. Welcome everyone to the What Makes a Good 8D Investigation webinar, sponsored by the RM 13000 Problem Solving Subject Matter Interest Group and the Community of Practice. Next slide. My name is Adam Rogers. I'm a member of the Subject Matter Interest Group. I'm kicking off our introduction today. And next slide. So a slight overview lets you know we will be recording today's webinar, and that link will be distributed following the webinar and will be also available on the AESQ website for your viewing. We will take questions in the chat feature, so if you can enter those in the chat, we'll do our best to answer those at the appropriate time. If we don't get to those, they will be answered after the webinar. We do ask that you remain on mute during the presentation to prevent background noise. Next slide. Our agenda here says 90 minutes. It'll actually be an hour, so we'll wrap this up at 10 Eastern Time. I'll present the introduction portion, and then the rest of the content will be presented by Pete and Catherine, who are also members of the Subject Matter Interest Group, to cover all of the key features of what makes a good 8D investigation. We'll wrap up with some question and answer time and a summary and close. Next slide. All right, a quick overview of 8D methodology, or the 8 disciplines methodology, give you the purpose behind this particular training. Our goal is to introduce quality and manufacturing associates to the 8D method as it's defined in the AES 13100 document and the RM reference manual 13000. We want to communicate why 8D has become the standard for root cause investigations that suppliers to aerospace engine OEMs will work to, and let you know that the reference manual RM 13000 provides the step-by-step help for properly documenting this root cause investigation through the 8D method. We'll talk a little bit more about the availability of these resources later on. Next slide. So 8D, or the 8 disciplines problem-solving methodology, was developed primarily by Ford Motor Company, late 80s, and was used to approach and resolve problems in their operations, typically employed by engineers and other professionals. It's a focused process to identify, correct, and eliminate recurring problems, and it establishes permanent corrective actions based on cause-effect analysis. Originally, it only had 8 Ds, 8 disciplines, hence the name, but as it evolved, a 9th step, or D0, was added to add initial planning stage called preparation and initial containment actions. So although it's still named 8D, it actually has 9 steps. It still this process still follows the logic of the PDCA cycle that was developed by Walter Sheward and W. Edwards Deming during the last century. So it has overall become a very prevalent methodology. You'll see that across several industries, and it's now been adopted by the AESQ as a standard for all RCC investigations. Next slide. So we're also here to provide support for this, for learning about problem-solving methodology. And so you heard me mention earlier the problem-solving methods subject matter interest group. The purpose of that group is to promote the effective deployment of the 8D problem-solving methodology across the AESQ supply chain. And this group is made up of subject matter experts from all of the AESQ member companies. And they are the ones who are accountable for the problem-solving portions of AS 13100, as well as the reference manual RM 13000 that lays out the problem-solving methodologies that we'll learn more about today. As you can see there in red, one of the primary goals, excuse me, of the interest group is to promote effective deployment of the reference manual using the community of practice. And the community of practice is open to any subject matter expert from the AESQ member companies and the wider supply chain. So some of the activities that we'll use include webinars, such as the one you're attending today, best practice sharing, development of shared training materials, conferences and papers. Next slide. So here you can see the members of the subject matter interest group. We have members from across the AESQ companies, member companies that you can see here from all of the major, or from many of the major aircraft engine manufacturers and suppliers. And this team meets together on a regular basis to ensure that the content of the reference manuals stays up to date and relevant. Next slide. So why are we holding this webinar in particular? We want to communicate what is expected to be part of a good 8D investigation. We want to be able to provide guidance when preparing an 8D investigation package. What does that look like? What things are included? We also want to be able to promote the available free documents and tools that can be used by any of the AESQ supplier to help comply with the standard. And we also be available to answer questions that any suppliers may have about the 8D process in general. Next slide. So there are other places where you can get help and support beyond this webinar. The AESQ supplementary materials webpage will allow you to download a copy of the RM13000 document, as well as the supporting templates that we'll review later for your use and reference. You can see the link there on your screen. The subject matter interest group can also be a source of information. They meet monthly, again, support continuous improvement of the reference manual, making sure the content stays up to date and relevant, as well as updating tools. We also want to ensure you know about the AESQ problem solving methods RM13000 community of practice on LinkedIn. This you can search for in the groups on LinkedIn and request to join. Our current membership is 168 users, but obviously we'd like to have many more than that. So we encourage you to check that out on LinkedIn and become a member of the community of practice. All right, next slide. So at this time, I'd like to turn the webinar over to Pete Tatey, who will be presenting the next section of our content.
Thank you very much, Adam. That was a great intro. Welcome, everyone. So now I'm going to talk about what makes a good 8D. So let's go to the next slide, and we'll start here. These are some of the things that we look for. I get involved at Pratt in reviewing a lot of 8D packages. Every quarter, we go through every escape we have, whether it's a commercial engine or a military engine application. And we go through all the 8D packages to see how robust they are. These are things I can tell you from practice that we look for. Is there a decent problem statement? Does it talk specifically about what went wrong, what was supposed to be right? Identifying the generation and escape points in the process. Where did the failure mode originate? How did the customer find it? And we failed to find it ourselves. Addressing what we call the three key causes, root causes: direct, which associates with the generation point; the detection root cause, which is associated with the escape point; and the systemic cause. We'll talk more about these three in a minute. Identifying the four key actions in an 8D: emergency or immediate containment. What are we doing to stop sick parts from going to the customer. Temporary or interim containment. What are we doing to help the customer get back into production through some temporary actions? What are we doing to permanently resolve the problem that occurred that initiated this whole chain of events? What are the permanent corrective actions? And can we validate their effectiveness? And then what are we going to do to prevent future designs from seeing this particular issue? That gets into the QMS updates, design manual updates, lessons learned, PFMEA updates. We'll talk more about all of that. Addressing sources of human error. This is one of the big changes that is coming out of AS 13100, this focus on human factors and human error. Catherine is going to talk to us more about this as we get into this presentation. I think you'll really get a lot out of that. There's a huge interaction between 8D and addressing the sources of human error. Coming up with mistake-proof or error-proofing solutions as corrective actions. Solid mistake-proofing devices that end up driving the prevention of those failure modes from happening. And then the alignment between the root causes identified and the corrective actions identified. Many times we see a misalignment there and in our reviews, and we want to make sure that there's true alignment between what we're going to do and what caused the issue. And this is a big one. This is another key interaction point in the AESQ world, AS 13100. You know how we're driving through chapter B and C, APQP and PPAP. Key element of that is the process failure mode effects analysis. That needs to be updated whenever there's an investigation that occurs based on a customer escape. What failure modes and causes did we learn about that were not anticipated? That requires us to update the PFMEA documents. And then what measures of effectiveness have we come up with to assure that this situation is now put to bed and under control and will not reoccur? So measures of effectiveness, that's pretty important. How do we know that what we did worked? And then finally, what preventive measures are we going to take? Are there, similar parts that go across that process where we had the failure mode that could experience the same sickness? And do we need to do anything with those particular related part numbers? So there are a series of questions that we've summarized, 10 questions. This is right off the 8D interactive tool that you could utilize with your teams. You could create a nice checklist to gauge, periodically 8D investigations. I'm not saying you have to do every single one with these questions, but use this to periodically do a health assessment of your root cause corrective action process. So these questions are geared toward helping us assess that health. And they're right here, was the suspect population identified and contained? Is the problem defined properly? Have we identified the direct detection and systemic causes? What kind of root cause tools were used? So again, you can go through the questions. I invite you to create your own checklist from that if you don't have one already. Next slide, please. So this slide was, we were inspired by MTU, one of our members of the AESQ, in coming up with, and this is in the RM 13000, problem solving types. Does every problem require all 9 steps of 8D? The answer is no. So what type of problem is it? If it's a simple type problem, for instance, I go to turn on my lamp and it doesn't go on. Well, inherently, we know the first thing we're going to do is check the light bulb. We'll replace it. Now I'll turn the switch. If it goes on, great. We'll move on. I don't need an 8D package to document that particular activity. Okay, same thing. If the flashlight doesn't go on, we're not going to take it apart and look for a wiring issue. We're going to change the batteries. That's a simple problem. We found it, we fixed it, we move on. On the flip side, if we have a issue, a failure mode, or a defective unit that gets out to a customer, that is going to require a full 8D. That will require activities such as population bounding, problem definition, creating the right team with the right skill set. So that will require a bit more than just a find and fix type issue. The middle shows a 4D approach. When we have a problem that's contained, it's in a local area, it did not get out to a customer, it won't require some of the upfront steps. And so this is a really good guide as to defining the type of problem and when we need to utilize all 9 steps of the 8D process. Next slide, please. So on one page, we summarize the 8D process. And I want you to note the key words. D0 is all about what we're going to stop. Okay, what we're going to stop in terms of non-conforming product to the customer, and what emergency actions do we need to initially instill? Do we need to put out some quality flags? Let the assembly floor know we have a suspect population of product. Do not utilize that hardware in your assembly. Do we need to notify a customer? This is where we get into notification of escapes or potential escapes. So there's immediate containment questions that have to be asked and answered. D1 talks about what kind of a team do we need to pull together? Do we need a materials expert, a special process expert in heat treat or plating or carburizing? Do we need an engineer who knows the design of that product very well? This is where we pull together the right team to have give us the chance of being successful. D2 is all about describing and defining the problem. We'll use tools like the 5W2H. Who, what, when, where, why, how, and how many. That's a fact gathering tool. And we've gotten pretty good at using that now. It really helps to define the problem and by gathering the facts. And that's all that tool is used for, is to gather the facts and give us guidance on what to ask. So in the interactive tool, we've got a detailed script around how to use that tool and a template. This is also where we start looking at a fault tree and the various paths that we might need to go down and investigate for that particular problem. The interim containment is D3. This is not part of the normal process. This is temporary. It could be as simple as gathering up suspect parts and inspecting them for a given failure mode and separating the good from the bad. It could be a rework that we're going to do in order to bring the product back to drawing specifications and then hence delivered to the customer. But in any event, it's temporary. It's not meant to last forever. D4 is where we start driving into the cause identification, the detection, the direct, the systemic causes. Tools like tree diagrams, fault trees, cause and effect analysis, 5 whys, ideation tools are used at this point. Or if there's hard data, Six Sigma tools like histograms, gauge R&Rs, gauge repeatability, reproducibility studies, studies can be used to help us determine the root causes of a given failure mode. D5 is all about solutions. What are we going to solve? This is the permanent corrective actions, unlike the temporary actions in D3. These are to address the causes and the failure modes that drove the actual investigation at the generation and detection points. This is where we get into mistake proofing controls, evaluate the actions on a solution selection matrix. At this point, we now move into D6, where we validate, are the corrective actions we came up with in D5 working? Are they preventing recurrence of the problem? Are they effective? And no, D3 and D6 have this tag at the bottom called "and verify." We may need to do some type of a test in order to assure that the temporary or permanent corrective actions we came up with do not cause other problems. Sometimes there's a test we're going to need to do. 7 gets into the prevention of recurrences. That's where we mentioned the read across activity, updating PFMEA documents like the flow diagram, the PFMEA itself, and the control plan. That leads to updating work instructions by the manufacturing engineer. Also, we might update quality management system procedures, standard work practices. So 7 is big because it's looking at related hardware and maybe hardware we haven't even designed yet. And so that's why we build these improvements into our documentation going forward. And finally is D8. That's where we congratulate the team, and there's no right or wrong way to do this. It could be at an all hands meeting, it could be an email, it could be a recognition at a staff meeting, a certificate, a pizza party. That's clearly up to the producer on how they want to do the congratulatory actions. Next slide, please. So what we call the Magnificent Seven. In any 8D investigation, it comes down to looking at, are these 7 items addressed in terms of the 3 causes, the direct, detection, and systemic causes. And then in terms of the actions, D0, the emergency containment, D3, the temporary containment, D5, the permanent corrective action, and D7, the preventive action. These 7 have to be addressed in any 8D investigation. And where we sometimes reject packages is we see a lack of addressing some of these items. Next slide, please. So now, this particular slide came out of an article out of the ASQ's automotive sector by a gentleman, John Casey, and he was benchmarking Toyota. And Toyota founder was Sakichi Toyoda, and he invented the 5Y process. And that was in the early 20th century. Toyota, in the Toyota production system, their problem-solving approach is primarily using the 5Y analysis. 1, because it's simple. 2, because it establishes cause and effect. And so the way they look at 5Ys is with this lens of 3 causes: direct and detection, which associate with the folks that do the work, and then systemic root cause, which associates with those that create the work, create the standard work, create the procedures. That's management, that's manufacturing and quality engineering. So there is this dividing line between those that develop the work and those that execute it. And that's how the causes are also placed, as you can see in the diagram. Pretty clever. Next slide, please. So a little bit more now. What is a direct cause? When we look at this, it is the cause at the generation point where the chain of events started. They are typically closest to the operator, and they associate with the immediate problem. Sometimes we refer to this as the manufacturing cause. You know, it might have been a tool that was not to size and it was used and it created a bunch of under low limit holes that were drilled. Detection, that associates at the escape point. How did the customer find the problem and we didn't? How did it get away? What was the last step in the process where we could have seen that failure mode, but we missed it? And that's the detection cause. And even our customer, our military customer, they focus on that a lot. They ask us all the time, okay, we understand you're working with your producer or supplier and why they missed it, but how did you miss it? I get that all the time. And then finally is the systemic cause. This is the one area a customer will immediately reject a package if they don't see how the system drove the particular failure mode and how it's being addressed. So systemic causes associate not only with read across, but what in our planning, what in our procedures, what in our design manuals could have led to this error and could lead it to many other reoccurrences on other product. And so that's important for us to address as well. And again, I'm going to emphasize the interaction point here. Human factors, PFMEAs. Those are two key interaction points. We're talking about RM 13,000 right now with 8D. Then there's RM 13010, human factors, RM 13,004, PFMEA and control plans, RM 13,006, which gets into process control methods. And so when we think about direct detection and systemic causes, we bring those other manuals in. And that's really one of the powers behind the AESQ reference manuals is that they link together. Next slide, please. 4 key actions. D0, we begin immediate protective action. How do we protect the customer from continuing to get bad product or product that's non-conforming? Also referred to as emergency containment. And again, the key word is stop suspect parts. So we might perform here now a population bounding exercises to determine all the suspect material. And then again, this would be part of the investigation. Where are those different sources of material located? It could include ascertaining from the supplier within 24 hours that they checked their production WIP, their finished stores, any product in transit that may be part of this population. D3 gets into the interim containment action, also referred to, as I mentioned, temporary. These aren't things we normally do as part of the day-to-day process, but it's to help recover. It's a countermeasure to help recover so the customer can continue to build. Might be over inspecting suspect material, deburring parts inside your 4 walls so that your customer can have good product. It could be a rework, could be a repair authorized by engineering. Next slide, please, gets into the D5 and D7 actions. So D5 is the permanent corrective action, addressing the direct and detection causes. This is the solutions that we're coming up with. And this could be adding a clearer work instruction, a better inspection technique, maybe a different type of gauge, different tooling, fixturing modifications. This gets into actually the solid, uh, corrective actions needed to resolve that problem and controls that will end up on the control plan. Preventive action, as mentioned earlier, this gets into read across, procedural updates, design manual lessons learned updates, PFMEA updates. Again, preventive actions impact product we haven't even made yet. Next slide, please. So what makes a good 8D? We have several examples here. Couple I pulled right out of the reference manual, which we have 3 different case studies that are based on real life situations. These are not made up examples, they're real. All the case studies in the AESQ reference manuals come from real life. And in this case here, we're showing an example of what we call an 8D A3 worksheet. This template is available under the supplemental material on the AESQ website, along with the other 2 templates we're going to illustrate. This happens to be an oil pan bracket case study. I'll go through this particular example, but in the interest of time, I'll just quickly browse through the other 2. What's nice about this particular format, it shows all the 8D steps. It's a great summary on 1 page. Behind the scenes, you'll utilize root cause tools available from the interactive tool that we provide on the same web page. But this serves as a nice 1-pager. We can call it an executive 1-pager, where you could quickly walk through the storyboard of the process. And it also gives us an opportunity to provide some picture of a given root cause tool. In this case, it's a histogram showing a process where we were making drilled holes under low limit due to a worn drill being used. And that was due to the fact that there was no counter in place to assure the operator it's time to change the tool. So you can walk through this and understand it from beginning to end because the problem statement is well defined, interim containment actions are well defined, root causes are well defined, the utilization of a drilling method called 5 whys, as we talked about, is shown right here in this template. And that helps us to understand the root causes of the problem. And of course, the corrective actions are well defined with a timeline. So, and it summarizes the direct and detection and systemic causes very nicely. Using a template like this can only help assure you're capturing all the 8D expectations any customer would want. Next slide, please. This is another template. This one is in PowerPoint. And again, it shows all the 9 steps of 8D along with a 3-dimensional look at 5 whys from a detection, a direct detection and systemic breakdown. So it shows the 3 legs of the 5 why, which goes back to that Toyota article John Casey wrote. It also gives us an idea of where in the process we are in terms of the timeline. So this would be another good template to use that would allow a customer to understand thoroughly where you are and whether you've addressed the Magnificent 7. And the third example, it's going to be a little tough to see here, but it's a Word document. On the next slide, it begins. This happens to be the format here, and it's a couple of pages. It illustrates all the 9 steps of 8D. It has excellent lead-in questions to guide you on what we're looking for. It has a supporting instructional template that one can use that's available off the 8D interactive tool. And so this incorporates, again, all the steps. The 4 key actions are broken out nicely. The key D0 emergency containment questions are all laid out flat. Generation and escape points are identified. 5Y drill down is there. So again, this is another excellent template available on the AESQ supplementary materials. Go to the next slide. This just shows an example using a part marking example. If you can go down one more, please. And one more again. What I just wanted to show here was an example of a 5Y being used that's part of this particular investigation. But notice this 5Y has a split. And one of the fundamental things in 5Ys that people make mistakes on is they force themselves down one linear path. Doesn't have to be that way. When we ask why, we may have 2 paths to go down. And notice the therefore test, which is used to assure continuity from layer to layer. That's very important. And there's some good training slides in the interactive tool relative to that I refer you to. So again, when we're doing a 5Y analysis, because this tool is so popular, most folks use it, but the common mistakes are they force themselves down one path when there could be a split, and they don't use the therefore test from the bottom on the way up. Also, you can identify corrective actions at any layer. Doesn't have to be the very bottom, which is typically the root cause layer. So I just wanted to make that point clear. Next slide, please. And one more. Great. So right now, what I'd like to do at this point, I've been, walked you through the Magnificent Seven, 3 causes, direct, detection, systemic, 3 root causes, and the 4 key actions, D0, D3, D5, D7. Also, we showed you 3 templates that work very, very well, and pointed you to where you can get supplementary material. At this point, I'd like to turn it over to Catherine, who's going to now walk us through the interaction of 8D with human factors. Catherine, it's all yours.
Thank you. Hello, everyone. I'm Catherine Katarina. I'm working for Safran as a supplier management system coordinator for the whole Safran group. But I am part of Safran Aircraft Engines. I'm leading also the subject matter of interest group for human factor, and some of you might have already attended some of our webinars. Next, please. So today I will try to link, in fact, our 2 groups. Why? Because as you know, the new revision of AS9100D, there is in chapter 10.2 an item that asks us to review any non-conformity and corrective action, and they say that it requires to evaluate the need for action based on human factors. Why? Because we need to ensure that we don't have any recurrence. So AS 13100 is, of course, requiring human factor management system, but more than that, we want you to investigate, and we have some details in that in the RM 13010. So we have in this manual some tools that are described. And just to let you know that we are in the process of updating it, and you should have it by the summer with some more examples and also some more tools. Next, please. So we have also reviewed the 8 steps of the ADs. And because we want to be compliant to the AS 13100, we have detailed some human factor contribution dedicated to AD and root cause analysis. Of course, it's very small and you can't see it, but we will send you all the details in the RM 13010, and also we can add it to this manual, the problem-solving manual. But something I want to point it out today is the D4 and the D5. So because we want to ensure that the root cause linked with the persons and the organization, we really want that these items have been studied and really detailed. So we will use some tools such as the Dirty Dozen, the Swiss cheese model, and I will show that on the next slide. Of course, in sorry, just can you go back? Of course, in the D5, we will have to challenge the solution. And maybe we can also use some solution already applied in other similar activities. In case you are in a big company, maybe you can find some of those as a feedback database. Next, please. So just to point it out, the Dirty Dozen, so you know some of them, I suppose, or the norms, the distraction, the stress, complacency, and so on and so on. It is very important to use some little guidance you have. We have some lists to review them in order to evaluate if one or more of them are one of the root cause. Also, something very important is to understand the difference with an error, so a human error that happens, and to be able to identify all the latent errors. And these are the contributive factors. These contributive factors need to be identified in order to prevent recurrence. A lot of them come from organizational failures, and they need to be identified because they really influence human performances. Of course, it is sometimes difficult to use such a tool because we are not used to, but you can find the detail of these tools in our manual. But also, we will try to add some real case studies in our next release. Next, please. So, the reference manual interaction, as you see, of course, today we are speaking about the AD investigation, so RM 13000, but it's very interesting to see that it is really linked to more of those. Of course, the RM 13004, which is the PFMEA and control plan. As we just said, the human factor manual, RM 13010, of course, it can be reactive when we try to understand the root cause linked to human performances, but it can be also predictive because during your new design, while you are working on new processes, it is very important to understand and to prevent from having human errors. Also, we have also the RM 13008, which is most of the time also very much linked with the RM 13000. So you see, in fact, all those manuals are independent today, but clearly very much linked, and you need, while you are reading across them, to think about that. Next, please. I think I give it back to you.
Sure. Thank you, Catherine. So we're about getting near the end here, so we'll be opening it for questions in a minute. But before we do that, we just want to make you aware on the AESQ supplemental website, supplemental materials, there is under the RM 13000 section is an 8D interactive tool. And so we're showing a couple of cartoons of that. What's nice about this tool, you can download it, it's in PowerPoint, and you can use the material within it to help you provide training to your folks internally. It has a lot of nice templates, all prepared mostly in Excel, some in PowerPoint and Word. And so there's a series of tools for each 8D step. So you can see an example here, tools for D4, and D4, of course, is the root cause analysis step. And so you'll have the tools for that step all laid out for you. And if you click on the actual title of the tool, that'll bring up some nice training slides around that tool. In this case, I think this says fault tree, and then there's cause and effect diagram and three-legged 5Y. If you click on any of that, it'll bring up some really nice training slides relative for that tool, as well as the template and a description of the tool and when you would use it. So next slide gives us a little bit more. This is the control panel. And what I wanted to point out here, if you forget what the 4 key actions are, click on any one of these buttons and it will bring you to a slide that describes the 4 key actions that we went over. If you click on any one of these buttons, D0 through D8, it will bring up the specific expectations for completing that step of the 8D investigation. Now, we actually pulled some of that in the backup slides of this presentation. So when you go to download this presentation from the AESQ website, you'll see the 8D steps in the backup material as well. And then, of course, we have the tools buttons and the key questions on the right. Over here, under key links, the top button links directly to the AESQ website where you could get at the supplemental material. And the link below is the link for the actual supplier reporting template that goes along with the Word template we described earlier. So everything is right there in the interactive tool. The next slide, I believe this is where now we can have a bit of question and answer session. So I'll ask the other presenters to come on, members of the subject matter interest group. And if there are any questions, we'd be happy to try to answer a few of them now.
Pete, the questions are in the chat box. If you open the chat, you can scroll through and see the questions that have come in so far.
Here we go. That's not it. Oh, here we go. Okay. Okay, here we are. Yeah, so what's the difference between 8D, 3D, 4D? I don't know. I've never heard of a 3D, but again, I go back to the slide that we showed up front, the different types of problems. There are 9 steps in the 8D process. The reason AESQ chose that process to standardize investigations is because it is the most robust. It includes everything we would need in any investigation. But again, that doesn't mean every problem needs to look like a 9-step 8D. You know, as I mentioned, there's some very simple problems that can be fixed rather quickly. You find it, you fix it, and move on. You break a pencil, the lead, you're going to resharpen the pencil and fix that problem. You don't need an 8D to document that. Again, not every problem is like that. Hopefully, most problems are find and fix. But some do get out to a customer and are of a more serious nature. And that's where the full 9 steps of 8D come in, where we have to population bound, where we have to segregate nonconforming material, come up with temporary repair actions or rework actions before we even get into solving the problem, and then preventing it on future product. So it's important for us to understand the difference in the types of problems. Some are contained very locally. They still require root cause analysis, but they may not require the population bounding or customer interface because they were found locally at the cell level. So hopefully that helps. Let's see. Oh yeah, what about updating the DFMEA as well to design out potential problems? You better believe it. That's a good point. Thank you. You know, some investigations result in design changes. Some investigations will result in design standard work being updated. But if it's a product that does go through a redesign because of some failure mode that was unanticipated, absolutely the design FMEA would want to be updated. That's design and process FMEAs are living documents. They're not static. And one red flag is when we look for a PFMEA and we see it's 5 years old and it hasn't been updated. And that's processes undergo changes all the time. So is it being used? Is it being used in conjunction with investigations? If I have a PFMEA that's 5 years old and we've had last couple of years several investigations around that particular part, then that PFMEA isn't being updated. That's a red flag. Process control system is not healthy. And so again, all these things work hand in hand together. See, I'll see if we can find another one here. I love the problem-solving type diagrams. That's not a question, but thanks for that. Thank you. That makes us feel good because we want to make sure that what we're putting together and putting out there for free on the website is useful to the supply base. And never ever be bashful about asking us or suggesting improvements. That's another reason to join the community of practice on LinkedIn. And Becky is phenomenal about making sure we get those questions and we answer them. We're very, very high priority in answering your questions. Let's see, we got another one here. Can we use the presentation content in our organization training modules? Of course you can. That's why we're doing this. When you use the material we put together to strengthen your internal root cause corrective action system, you're strengthening our root cause corrective action system. We're all one supply chain, and it has to be strong at every link. So yes, of course you can use this content. Is this diagram available? I'm not sure what diagram Mark Green is referring to. If you let us know specifically, I have a feeling the answer is yes. I'm just not sure what diagram you're referring to, Mark.
It was answered later. Most of the diagrams we use are actually in the reference manuals.
Yeah. Yeah. And seems like 2D is similar to Just Do It. It is. Absolutely, it is. Okay, that's good. Let's see. Oh, good question here. Is there a standard or recommended turnaround time for each D step to additionally qualify it as a good 8D? Wow, this is really a powerful question. I don't know if any, I'll give it a quick stab and then turn it over to my colleagues. Every investigation is different. You know, again, some problems will have lesser turnaround time than others. One red flag is when the root cause investigation starts dragging out. There's a quote from a Japanese quality guru we used to work with named Yuzuru Ito. And he said, the further in time you get away from the root cause, the further you get away from the truth. And without immediate reaction to data, there can be no improvement. This is very true. And so it is very important up front, like D0 should be done within, I think we now say in AS 13100, 48 hours for notification and containment, emergency containment. The root cause analysis portion, D4, again, that varies depending on the type of problem. What if it's a problem that involves materials and you need a materials engineer and you need to do lab tests? That's going to take additional time. So if it's a machining type problem or a measurement problem, those probably will take less time. The things we don't see, heat treat, carburizing, anything to do with the structure of material will take additional time. Sometimes we need to incorporate a test. That's going to take time. And if we have to develop a test, that'll take additional time. So it's hard to answer that question and provide guidance on what should the expected time be. We know 1 year is not acceptable, right? Again, but 5 minutes is certainly not acceptable either. How well did we really dig into the problem? And we can see that with 5 why analyses that we review, that there wasn't a lot of depth. So there's got to be a balance in there. A balance between putting in the proper time and depth so that that problem doesn't recur again, from dragging it out over, you know, to the point where you forget what the actual facts were in the case. So anyway, I'll turn that over to my colleagues if you have any additional comments on that.
Just that what you said, Pete, is reiterated in the standards where it says that the steps are appropriate, timescales are appropriate to the risk involved with the issue. So they can vary, and they also should be coordinated with acceptability to the customer.
Right.
So between those two.
Yeah, and that's important there is establishing the timeline for each 8D package. That's typically what our SQEs and quality engineers who lead these teams will do is establish that timeline, and that's what gets, that's what they march to, essentially. Again, it'll all be different. Let's see. Oh, here's one I think Catherine would love. How should we
Maybe I
approach
can,
the
just before the question,
Oh, sure.
if I can add something, what we often say is that we want the D0 in 48 hours and the D5 in 30 days. This is what we request. And then you have more time to complete, and then you have mainly for corrective action request, for example, you have until the 3 months. This is what we like to have when we have a non-quality event or a corrective action request. So
That's a great point.
30 days and 3 months.
30 days to give us the plan. Yeah.
Just the stop bleeding, the stop bleeding action.
Yep.
To be in 2 days.
Okay. Okay, so to stop the bleeding within 48 hours and the corrective action plan within 30 days. And of course, the corrective action plan will have a timeline to it. Yeah. Catherine, here's a question. How should we approach the human factor in the root cause D4? When we use 5 whys, we always try to address the system flaws.
So, in fact, most of the time when you do your root cause analysis, sometimes you come across human error. So when you have the word human error, we don't want to see any more of these in your ADs. We want you to go further behind that human error, and so use the tools that are proposed in the human factors manual. Is it your answer? Is it okay for your answer or?
Yeah, no, that's very good.
Okay.
Yeah, let's see. I know we're here's a question. Why does preventive action, why is it required since we address the causes of failure in permanent corrective actions? So I can give you my take on that. They're distinctly different. Permanent corrective actions address the issue that started the chain of events. Why are the holes under low limit? Why was the marking incorrectly applied? Whereas preventive actions suggest, or not suggest, what are we going to do to assure that the failure modes and causes that occurred here do not reoccur elsewhere, and that it could have been caused by a quality management system, procedural misinterpretation. We may have had a marking issue caused by misinterpreting the spec. Let's make the spec clearer so that that misinterpretation doesn't happen again on other part numbers. So the direct cause is why the marking was incorrect to begin with. Well, it was called out in the work instruction incorrectly. Why was it on there incorrectly? Because someone misinterpreted the spec. All right, so the direct cost says fix the work instruction and fix the program that does the marking. But the preventive cost says revise the spec so we don't have that misinterpretation going forward. So again, they are different. They are quite different. I don't know if anyone has anything else to add to that.
No, it looks like we're at time, Pete. I don't know if we want to.
Yeah, I think we are. So we're going to close up shop now. And I'll tell you, we want to thank you all for joining. I saw, I think it was up to like 249 folks on. It was well attended. We hope this served some value, and feel free to reach out to the subject matter interest group if you have further questions. We thank you for your time. There will be a video of this recording posted on the AESQ website within a few days, and an email will be sent to all registrants with the link. So you'll have access to it and the materials that we mentioned. You can use them. Please use them. Anything we provide on the supplemental materials website, take it and use it in your own internal plans. With that said, thank you all very much for participating, and we look forward to seeing you again on future webinars.